Welcome and thanks for joining us. My guest today is Victor Brown. He's the Vice President and Chief Technology Officer for U.S. Public and Federal Markets at IBM. Victor, it's great to have you with us.
Hey, thank you, Tom. It's great to be here.
And of course, we're talking about cloud. Big topic, remains a big important topic for federal agencies. And I want to start with some of the fundamentals here.
Absolutely.
And people have to determine which workloads they want to move to the cloud. And that's a more complicated question than it sounds the way it's written, because do you pick a cloud provider knowing the workload you have, or if you have multiple cloud providers already, which workload goes which place, and how do you prioritize it all? So talk us through that situation, picking the workload, picking the cloud, and how it all adds up.
Absolutely. It really, when you think of cloud, a lot of people think of cloud as something else other than their enterprise. Cloud is specifically a part of your enterprise, and you should treat it as such. And when you're choosing workloads, think about what the workloads have to do when they're being deployed. Regardless of if it's a cloud or if it's on-prem, make sure you understand the dependencies of the workload, what it has to do, and also never forget what it might cost if you do deploy it in multiple locations. Because in a lot of cases, what customers do is they think of cloud as something else other than their enterprise. And they don't think about all the things that go around deploying a workload. Even connectivity to the cloud has a cost. Connectivity back from the cloud has a cost. And you should always think about the fact that there's usually not just one cloud provider in the mix. There's usually a group of cloud providers, and you have to think about a multi-cloud hybrid environment, because your enterprise doesn't go away because you deploy it to the cloud itself.
And you mentioned dependencies of an application, and if that application were originally deployed in your own environment, your own mainframe, you know the dependencies.
Correct.
Hopefully they're documented in some manner. So therefore, should your cloud providers mimic exactly the environment you have in your mainframes, or are there services in the cloud that maybe, given those dependencies, you might be able to improve things?
In most cases, when people move to the cloud, if they're doing a basic lift and shift of their workload from one location to another, especially when you're dealing with classic compute, when I say classic compute, I'm talking about just regular systems that, Intel-based systems, AMD-based systems with memory and usually the same type of storage that would be in your data center. Usually in those situations, most customers don't really, they just lift it, move it, and say we moved it to the cloud. They haven't modernized it, they haven't optimized it. They don't even know, in a lot of cases, if the environment is actually suitable to actually run that workload. They just know that the hardware is big enough to support it. So you need tooling that actually understands how to leverage that workload appropriately in that cloud environment, which means you have to have the capability to understand how much utilization is going on, how suitable is that client for that particular cloud environment and the application, as well as the databases that are dependency behind it, and how it performs on the cloud versus being on-prem. Quite often you end up with a hybrid environment in order to meet all of those requirements. And the service level agreements have to be thought about as well. Every time you add a 9, it's a whole lot more hardware.
Sure.
And software. So you need to think about that as well.
All right, so a couple of questions. You mentioned the database dependency and the possibility of having a hybrid actual hosting for that workload, which the implication is, well, the database stays where it is.
In some cases.
The application might be in the cloud or vice versa, but either way you have data traffic going back and forth, and that could be a major cost factor, correct?
Absolutely, absolutely. And when you put it out on the cloud and you think about those costs and the sustainability around those costs, you have to think about the fact that you are moving data back and forth. Even if it's a basic lift and shift, you're accessing that application. So you're going to have egress and ingress. A lot of times you don't have ingress charges, but you have egress charges when that data moves from the cloud. And you have to think about how you want that optimized application to behave now that it's deployed in a cloud environment. Sometimes you're in better shape leaving the data where it is, building a data fabric solution around it, and accessing it the most optimal way it needs to be accessed in order to provide the SLA that you need.
And you mentioned tooling that understands the utilization, et cetera. So this is another application that you examine your potential workload with.
We have tools like that, like Astana and things of that nature that actually can go out, and Turbonomic, can go out and look at your application as it's running, figure out where the bottlenecks are, and help you optimize that workload now that it's deployed in a cloud environment. And when I talk about cloud environments, I always talk about a hybrid cloud environment, because there's no such thing that I've seen in any enterprise where they don't have anything on-prem. In a real enterprise, you're going to always have something on-prem, even if it's just the people. And you have to think about that as being part of your enterprise ecosystem, and make sure your security boundaries and your monitoring boundaries extend throughout the entire hybrid cloud ecosystem. And when I talk about a hybrid cloud ecosystem, I mean on-prem, I mean multiple clouds, I mean single clouds, and I also mean private clouds that reside in your current data center. There are assumed to be private clouds in every major enterprise.
Yeah, sometimes it's just a closet, but it's still a crucial closet.
Absolutely, as long as you have applications running there. And it doesn't take much to make a cloud. You know, they vary in size. But usually enterprises don't think about their private infrastructure as part of the private cloud environment.
And on this question of the behavior of the application,
yes,
presumably you want it to run faster when you move it to the cloud than slower. That would probably be a virtue people would be after. But is it possible with cloud providers to run some models of different architectures before you decide on your SLAs, decide on your architecture and your deployment plan? Can you test drive before you buy?
Absolutely you can. And most cloud providers provide that. But keep in mind that when you're in a multi-cloud hybrid environment, that's a different model than the model that you get from a single cloud provider. That's why you need to be working with organizations who've done hundreds and thousands of these things. And that's one of the things that we pride ourselves with in IBM, is that we've been an enterprise provider for many years. And we've seen how enterprises are built and what is required to actually run an enterprise. And you'd be surprised how similar it was 30 years ago as it is today.
I actually remember that. And I was going to say, in federal agencies, you probably have a lot of S370 emulation still running to this very day.
Absolutely, because it works, right? It works, and a lot of it scales very well, and it's continued to keep up with the modern workloads. But we've done a lot of modernization as well across the entire enterprise from a hardware and software perspective to support these types of ecosystem environments.
And in thinking about the budgeting, the planning, your cloud estimates, that is a non-trivial task, I would think, because you really don't know exactly what your traffic is going to be. And the traffic constitutes a big part of cloud costing.
It can, especially if you're dumping petabytes into the cloud. It'll let you in, but if you start pulling it back out, you really have to pay. So when you're doing your development and you're looking at this from an enterprise perspective on what I want this application to do, who the audience of the application is, how that audience will be accessing the data, and how the data that's being generated will be reused, that gives you a really good idea of how that cloud architecture needs to be. And again, a lot of times you can't just do it all in one cloud. And a lot of people, I've seen them do this before. Oh, we're going to just pick only cloud services in a single cloud. And that's what we're going to deploy to. And that can be good in some cases, but keep in mind, remember the dependencies that we talked about? When you're dependent on cloud services in a single cloud provider, quite often you have locked yourself into that platform. Whether you want to be locked into it or not, you'll lock yourself into it because it's a dependency on your application in order for it to execute properly. I always talk to customers about hybrid cloud architectures and leveraging hybrid cloud platforms that allow you to actually build once, deploy anywhere. And that allows you to actually have the capability and flexibility to move whatever you build from cloud provider to cloud provider and optimize the workload and move it on-prem or move it to a mainframe. or move it behind the firewall and disconnect it from the cloud. It's a different way of thinking about the problem set.
And the capability of moving a workload from commercial cloud to commercial cloud presupposes that the clouds all have a certain set of services that they have in common. I mean, one of the differentiators among clouds is their list, their catalog of services.
Sure.
5,000 different services from this cloud, 4,720 from that cloud. But there must be a certain basic needed set that they all have in common?
They all do have infrastructure as a service in common. All of them do. And so the way that the hybrid cloud infrastructure workloads are deployed, they support the capability to actually do that deployment for you, and it understands each cloud platform it sits on, all of them, including on-prem. And it actually does that deployment for you behind the scenes. And then it deploys the application on top of that. So the storage, the compute, the speed of the storage, the different types of regions you may have to deploy into, it understands how to manage that. Then we look at it, we use what we call AIOps to actually look at that multi-cloud environment as a single cloud environment, so that then helps you optimize it across the board.
So you need almost a kind of control and optimization layer between what it is you're developing or what it is you're hoping to deploy and the cloud providers.
Yes, it's basically a deployment platform that sits on top of the infrastructure that all cloud providers support.
All right. And in the planning and budgeting, who should be involved from an agency? This is not, doesn't sound like it's something strictly for the CIO staff to get involved with.
Correct. You have to think about every aspect of what you're moving to the cloud and what you're keeping on-prem. And don't forget, we talk about the data quite a bit because everything revolves around the data. But also don't forget you have service level agreements that you have to take into consideration as well. And cost is relative. If you get a cheaper price to deploy something but it's unusable, have you really saved anything? You really haven't, because the fact is you have to build something that's usable, that can be optimized, that you can take advantage of. And yes, you're paying for it in a different way, but you have to think about what paying for it in a different way means from a budgeting perspective, from an O&M perspective, even from a long-term CapEx perspective, because there may be some things that you need to move back after you do deployments on the cloud, back on-prem. So you never want to throw out everything, just saying, oh, I'm gonna just move it all to the cloud and move forward. Sometimes you get out there and you find out that there's certain things that need to perform where they're sitting. And what you do in that situation is you architect the application to take the best of both worlds out so that you put the right parts on the cloud and the right parts on-prem, and you share the data in such a way that you end up in a hybrid environment that's actually executable.
Yes, because network speeds and bandwidth have expanded so much exponentially in recent years. We're getting to the 400 terabit to the desktop type of era and so on, which means that latency and transfer is probably less of an issue than it was a while ago.
No question. Even on mobile networks, 5G networks, the ability to deploy across these types of ecosystems to the edge has changed the way that we actually do business from day to day. And we take it for granted. When we jump in a car and you realize that you're using an application that's crowd-driven, it's running across multiple clouds, it's using content delivery networks, it's then reaching back for data that it has in its own data center that it needs. Some of it may be in the cloud, but I guarantee you they have some of it in their data center that they're executing upon. And it's changed the way that we actually think about cloud. We begin to blur the lines, which is why I say that cloud is really, when you think of cloud, you need to think about your entire enterprise, because the lines are now blurred. Even if you deploy something very large, it usually goes across multiple cloud environments. It never sits in one.
And you mentioned the CDNs, the
content delivery networks. Yes.
That brings the edge into the equation, and you really can't ignore that either.
You can't ignore the edge. In fact, to me, the edge is the most important part of cloud, because it decides where those high efficiency applications need to be deployed. Usually when people deploy something on the edge, it's because they need an immediate answer, or they need access to the data with the least amount of latency, or they're feeding data into the cloud or into another application through that edge connection via a sensor. And the way that the connectivity now works has changed significantly over even just the past 5 to 7 years. We're beginning to see the capability to have mobile devices that can actually do everything you need them to do on the edge and provide that information back. So it's a different way of thinking about the whole problem set than it was before.
And you mentioned, too, the multiple people that need to be involved, the multiple functions that need to think about this. And that reminds me of something you said earlier, and that is each 9 of what you think you need for reliability that you add has an exponential effect on the cost of it.
Absolutely.
And so it sounds like people need to be realistic about uptime they actually need and really not necessarily go for 5 nines or 6 nines on everything they put in the cloud.
100% true. When you add, you basically, to get to those 5 9 implementations, you really have to have 2 environments running in a hot configuration to a certain extent. And when you do that, that means you're paying for 2 running environments and replication of data between those environments in a hot configuration. When you first deploy it, it doesn't look too bad. Over time, it adds up. And you have to think about that. And also, there's a lot of high-speed storage that you can put on-prem to take advantage of some of that. Even appliances that you can put at the edge to do that significant processing that you need at the edge. And only move the data to the cloud that needs to be moved to the cloud, and only move the data back on-prem that needs to be moved back on-prem. It works both ways.
And can you also fine-tune your SLA such that, I mean, the reality is a lot of federal applications are roughly 9 to 5.
Yes.
And you maybe need the higher level of 9s of reliability, 9 to 5, but overnight you can dial it down a little bit.
Yes, but usually that's when a lot of maintenance takes place. And those maintenance cycles do require quite a bit of power to execute. But you're right, you can dial down on the area of people connecting to it at night.
Sure.
You know, and it's usually after 9 p.m. because you do have to take the West Coast into consideration. And if you want to go out 2 more hours, Hawaii as well.
Right, and then next thing you know, you're in Guam.
Exactly. You know. So you have to think about
the Chinese embassy, and you're right back around the globe.
Yeah, you kind of have to look at the bigger picture, and we do live in a global society now, where there's some access 24/7. But I always tell people when they look at their taxes, I use this all the time. People say, well, you know, when I'm sending in my taxes through TurboTax, it's going directly to the IRS. I said, no, it's not.
It's a lot of hops there.
I said it goes to Intuit first. They check it out. If it doesn't check out there, then they'll tell you, and it never goes to the IRS. So you're not really sure how many environments it hops through before it gets there. But realistically, and as fast as they do it, chances are it just goes into their environment. They check it out. They transmit it to the IRS. They give them an okay, and they wait for a response back. But even that is a hybrid cloud environment. It's a hybrid multi-cloud environment. I guarantee you they have some systems on-prem to accept that initial connection where they first check it. Then they may store it in the cloud, but I bet you they cache it locally first, probably in a series of SSDs to store it. Then, just in case it doesn't transmit properly, they want to keep it there until it does successfully transmit. And then once they get the yes, then they remove it and start with the next one. So some of these things we take for granted are really complex environments behind the scenes. And each one of those has a cost. Has a latency cost, it has an O&M cost, and it has a cloud cost and a hardware cost and software cost to maintain it over time.
And the way you describe all of this and the approaches required, it's almost like computing and people involved with the computing of an agency need to make a cultural shift.
They do.
In the way they think about it.
They do. You have to think about the problem differently. Before, a lot of times in the agency, they would develop custom applications that leverage the environment that they currently had in their data center. Now you have to think about how this application actually has to work across an entire ecosystem from end to end. And that ecosystem includes cloud, on-prem, edge, and even devices like mobile devices that sit at that people leverage, that they access it with. How do you deploy something that needs to have 1 million concurrent users on it? It's going to look totally different in an environment like that than it would on-prem, because you can take advantage of that content delivery network that we discussed, and we can do it across multiple clouds. And there are providers that provide that capability across multiple clouds as a third-party provider too, and you have to understand how they fit into the mix. Then you add up all those bills and look at the culture around that and figure out what really makes sense. And a lot of times you don't really know until you try to actually do it, because modeling that is harder than it seems. It looks simple when we talk about it, and that's why I highly recommend that agencies get some help up front from people who've done it multiple times, so that they at least understand what they're getting themselves into, because it looks simple. And that's why you see the difference between Cloud First and Cloud Smart. Cloud Smart thinks about those smart things that you need to take advantage of to move to cloud.
It sounds like agencies almost need a test and measurement lab platform for modeling different cloud deployments.
Well, there are some things like that, but it really depends on the workload. Some workloads, you kind of know what you're dealing with. If you're moving a VMware image from one environment to another, or a VM image from one environment to another, and that's all you're doing, you kind of know what that image does. Mm-hmm. Then you just have to look at how it's being leveraged and how it runs on its new deployed platform, and that's when you get into the tooling, and then you optimize that. You may be able to get 10 times more workloads on the same system than you could when it was on-prem. And then you optimize the use of the system. It may be cheaper to add memory or compute or add storage directly on the box than it is to use the storage that's actually in the cloud, and you replicate it on the box itself. So you have to think through those types of things, because you have a different hardware footprint and software footprint than you had previously. And there's a cost to that, to using that software footprint too.
Amazingly, even nowadays, adding memory always helps a lot of computing problems.
A lot of times it does.
Yeah.
But we've seen instances where we thought it was a memory problem, and then we'll run a tool that takes a good look at it, and we find out that it was something in the application. Mm-hmm. Maybe the way the application was written, it didn't expect things to come back as fast as now it's coming back, since you deployed it on a piece of hardware that's more capable. And it changes the way you think about the problems.
It's a good thing memory is cheap.
It can be, but in cloud, at least you can test it pretty easily. You know what I mean? You can test it, run it, and then see what happens, and then dial it back a little bit and see what happens. But I've seen people put cloud deployments out there and they throw hardware at it to try to make it perform, and that's not good either. You really need to know what problem you're trying to solve.
Yeah, it's somewhere in your code is where
exactly.
you got to get to first.
I've seen garbage collection hem people up, wondering why things are so slow, and it's the way the application was written and the parameters that were set in the application on how it performs with the memory that's available that affect the ability of the application to execute on the cloud. When it was on-prem, it was perfect. But now that it's on cloud, the dynamics of the hardware changed, and they didn't take that into consideration. So that's a cultural change as well. It doesn't sound like one, it sounds like a technical change, but the reality is, from a cultural perspective, you have to think about the problem differently than you did previously.
All right, in the final moments we have, what's your best guidance for agencies, top level, to move to the cloud and make those decisions?
Think it all through. Have a good cloud partner to go with you. When I say cloud partner, I'm talking about a company partner that understands your enterprise as it sits, the cloud environments that you're leveraging, and how to perform in a hybrid multi-cloud environment. And use someone who has a lot of experience doing it. Don't just go for the cheapest one. Go for the one that has the most experience doing it. Believe me, there's a lot of money spent on doing things 3 or 4 times, and then when you add that up, it's no longer cheaper. You're better using someone who actually has the capability to do that. And also go with a partner that has a lot of experience on the enterprise side too. And the reason I see that's important is that I know that in IBM, every time I walk into a large customer, I never talk to them about cloud alone. I talk to them about their enterprise and how their enterprise can leverage mainframe with the cloud, hybrid mainframe cloud deployments, how classic compute can play. What are we looking at next with quantum computing? What are we thinking about next with quantum cryptographic capability? And what's next after all of this? Because if you think back in time, we were here before. The original mainframes were the cloud. In the 60s, we had cloud. We still have it today. We do. The difference is that there are different types of platforms we can deploy to now, but we still have them. Today's mainframe is infinitely more powerful than many clouds. So when you take advantage of the power of today's mainframe and combine that with cloud, it changes the way you look at the problem set. But you need someone who understands your entire ecosystem in the end to be your partner on that journey.
Well stated. Thanks so much for joining us.
And thank you for your time. I really appreciate it.
All right. My guest today has been Victor Brown. He's the Vice President and Chief Technology Officer for U.S. Public Sector and Federal Markets at IBM. I'm Tom Temin. You're listening to Federal News Network. Let's go back to the studio now for more of the Cloud Exchange.